All right, in this video on parametric equations, I want to talk to you about how to bounce back and forth with lines and other curves between parametric equations and Cartesian equations. So a line segments, and many other curves can be defined parametrically. And a line can be parameterized by letting x equal the initial x value plus some number times t, and y can equal the initial y value plus some number times t. So let's look at an example. We want to draw and identify the graph of the parametric equation or parametric curve determined by x equals 3 minus 3t and y equals 2t for t between 0 and 1. All right, so I'm going to put this in Desmos. I'm going to start it down here. So we would have 3 minus 3t and 2t. Okay, now if I look at this, it's just this line segment that starts at 3, 0 and ends at 2, 0, 2, or vice versa. What you can do to see the way it's traced is go 0.2, 0.3, 0.4, 5, 7. And you see it starts at the 0.3, 0 and traces kind of up and to the left till you get to the 0.2, 0. That's important because it's no longer just a line segment. It's also a line segment that has direction to it. Okay. Oop, let me back up here. And now what we want to get is we want to convert this to a Cartesian equation. So the easiest thing we can do here is we know that when t equals 0, if you plug 0 in, that's because that's the beginning of this interval, you would get x equals 3. And when t is 0, y is also 0. And then the end of this is when t equals 1. So when t equals 1, you have x equals 0 and y equals 2. And that corresponded with the line segment we got here. It started at 3, 0 and ended at 0, 2. Okay. So if I have x equals 3 minus t, x equals 3 minus 3t, I can solve that equation for t and get t equals x minus 3 over negative 3. And then I could substitute that into the y equation for t. All right, so it's x minus 3 over negative 3. And I would have negative 2/3 x plus 2. Now, if I go back over here and have y equals negative 2/3 x plus 2, it's going to give me the entire line here, not just the segment. So I would have to restrict the domain to be as x goes from, x goes from 0 to 3. And that would give me the line segment for that one. Okay. All right, so now we want to kind of go backwards and find a parameterization for the line segment with endpoints -1, 3 and 3, -2. Now, if you remember, you can parameterize a line according to this, where you have x equals the initial x value plus at and y equals the initial y value plus bt. So x is going to equal -1 plus at, and y is going to equal 3 plus bt, because this is our x naught, y naught. Okay. Now, if I let this point occur, now this didn't tell me the t values that I could use. So I'm going to let that point work when t equals 1. Okay, so when t is 1, you have x equals -1 plus a, and that should come out to be 3. And when t is 1, y equals 3 plus b, and that should come out to be -2, because when t is 1, I plug it in for t for the x equation and set it equal to the x value for this point here. And similarly with the y value. Now that I can solve each of those for a and b. A would equal 4 and b would equal -5. So now I would have my equation x equals -1 plus 4a and y equals 3 minus 5t. Okay, now if I go ahead and bring Desmos over, and I have -1 plus 4t, that should have been a t right here, and 3 minus 5t. Notice I'm getting the line segment that has -1, 3, and also 3, -2 in there. Okay, so I have the parameterization. Also, notice the t values go from 0 to 1, and that's how I defined it by how I parameterized it. Had I let t equal 2, then I would have gotten different a and b values, but it still would have been the same line segment. It just would have taken it from 0 to 2 in t values to graph the entire parameterized curve. All right, guys, that's it for this one. Hope that was helpful to you. Take care.